Hi friends, welcome to all. In this video, we are going to solve this packet tracer activity. Configure a numpad standard IPv4 ACLs. Before coming to this activity, friends, if you like to get any CCNA version 7 online classes or any technical support, you can contact our team using our website. Link you will get from the description below. And if you like to get these type of technical videos in future, consider subscribing. And don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Okay, now back to our activity. Here we can see our addressing table. Coming to the objectives, part 1, plan an ACL implementation. Then in part 2, configure, apply and verify a standard ACL. We will go through the scenario. Standard access control list, that is ACLs, are router configuration scripts that control whether a router permits or denies packets based on the source address. This activity focuses on defining filtering criteria, configuring standard ACLs, applying ACLs to router interfaces, and verify and testing the ACL implementation. The routers are already configured, including IP addresses and enhanced interior gateway routing protocol, that is EIGRP routing. That's fine. They fully configured this topology with IP address. Also, they configured EIGRP. So here we are going to plan and implement access control list. We will do it one by one, coming to the instructions. Part 1. Plan an ACL implementation. Step 1. Investigate the current network configuration. Before applying any ACLs to a network, it is important to confirm that you have full connectivity. Verify that the network has full connectivity by choosing a PC and pinging other devices on the network. You should be able to successfully ping every device. Yes, that is correct. So before implementing access control list, we must verify the network has full connectivity. So we will verify here. We will test end-to-end connectivity. Here we can see our addressing table. I will ping from PC1. We will go to command prompt. First of all, we will ping to PC2. We will get its IP address. Ping to PC2. And we are waiting for the replies. Here we can see it's working. Now we will ping to PC3 from PC1. We may get one request timed out, and here we get the replies. Also, we will ping to this web server. Here is the IP address. Ping to the server. Pinging, okay. Yeah, we get the replies. It's working. We verified this network and it has a full connectivity. Now in step 2, evaluate two network policies and plan ACL implementations. The following network policies are implemented on R2. The 192.168.11.0/24 network is not allowed access to the web server on the 192.168.20.0/24 network. All other access is permitted. Here we are going to implement this ACL on this router R2, and here we can see this network 192.168.11.0/24, PC2, S2 and this interface, that is a G0/1. This network is not allowed to access to this web server, that is 192.168.20.254, that is the IP address of this web server. And all other access is permitted. Okay. To restrict access from the 192.168.11.0/24 network to the web server at 192.168.20.254 without interfering with other traffic. An ACL must be created on R2. Okay, the access list must be placed on the outbound interface to the web server. A second rule must be created on R2 to permit all other traffic. Yes, we have to create that access control list in this router R2, and we have to implement that ACL in out direction. So this is the first policy they specified here. Here we can see the second one. The following network policies are implemented on R3. So the 192.168.10.0/24 network is not allowed to communicate with 192.168.30.0/24 network. All other access is permitted. Coming to our topology, here we can see that network 192.168.10.0 network. So this network is not allowed to communicate with this network, that is 192.168.30.0/24. So we have to create that access control list in this router R3, and we have to implement in outbound direction. To restrict access from the 192.168.10.0/24 network to the 192.168.30. Oh, your 30.0. Okay. 30.0/24 network without interfering with other traffic, an access list will need to be created on R3. Exactly. The ACL must be placed on the outbound interface to PC3. That means we have to implement to this interface, that is G0/0. A second rule must be created on R3 to permit all other traffic. Yes, we will do that. Now we will go to part 2. Configure, apply and verify a standard ACL. Step 1. Configure and apply a numbered standard ACL on R2. Create an ACL using the number 1 on R2 with a statement that denies access to the 192.168.20.0/24 network from the 192.168.11.0/24 network. Here they given the command. In global configuration mode, we have to give access list 1, deny this network, that is 192.168.11.0 with this wildcard mask. We will give that command in this router R2. Enable conft, and here in this global configuration mode we will give access list. Then I will put a question mark here, and we can see we have to specify the number. Here we are going to give this IP standard access list. So we'll give 1 numbered access list. Okay, then again a question mark. We can give deny, permit or remark. Here we are going to deny a particular network, right? So we can give deny, then we can specify address to match. So here we are going to deny this network 192.168.11.0/24. we will give that network here 192.168.11.0. then we'll put a question mark. Now we have to give its wildcard bits. It is 0.0.0.255. then press enter. By default, an access list denies all traffic that does not match any rules. To permit all other traffic, configure the following statement. Access list 1, permit any. Okay, we have to give that 2. Access list 1, we are going to permit any. Before applying an access list to an interface to filter traffic, it is a best practice to review the contents of the access list. In order to verify that it will filter traffic as expected. So we will verify using this show command, show access list. Okay, we will go to this R2 and we will give that command. show access list. So we are in global configuration mode. We can give it a do command, do show access list. Otherwise you can give in privileged exec mode. And here we can see standard IP access list to 1, deny this network, then permit other traffic. Now for the ACL to actually filter traffic, it must be applied to some router operation. Apply the ACL by placing it for outbound traffic on the gigabit Ethernet 0/0 interface. So coming to our topology, here we can see that interface G0/0, which is connecting to this network. They given a note: in an actual operational network, it is not a good practice to apply an untested access list to an active interface. Okay, so here we have to go to that interface gigabit Ethernet 0/0, and we have to give this command IP access group. We created this access list to 1, then outbound direction. We'll go to R2 and we will give that command here. We will go to that interface, that is G0/0. Then we will give IP access group 1 out direction. We'll put a question mark, and here we can see inbound packets and outbound packets. We will give out. Coming to step 2, configure and apply a numbered standard ACL on R3. Create an ACL using the number 1 on R3 with a statement that denies access to the 192.168.30.0/24 network from the PC1, that is 192.168.10.0/24 network. Here we can see that command access list 1. We have to deny 192.168.10.0, and here they given the wildcard mask. So we will give this command in this router R3. Enable. Then we will give a conft. Here we will create that access list, that is 1, and we are going to deny this network 192.168.10.0. Then we have to specify its wildcard mask 0.0.0.255. By default, an ACL denies all traffic that does not match any rules. To permit all other traffic, create a second rule for ACL 1. Yes, we have to give this command access list 1 permit any. We will give that here. Access list 1 permit any. Now we will verify that the access list is configured correctly using this show command, show access list. Here we will give it a do command, do show access list, and here we can see standard IP access list 1. We denied this network, then we permit all other traffic. Then apply the ACL by placing it for outbound traffic on the gigabit Ethernet 0/0 interface. We have to go to this interface, and we have to give IP access group 1 outbound. So here we can see that interface G0/0, which is connecting this network. We will go to that interface G0/0, and we will give that command IP access group, it's 1 outbound. Coming to the last step, verify ACL configuration and functionality. Enter the show run or show IP interface gigabit Ethernet 0/0 command to verify the ACL placements. Okay, just we will try in this router R3. You will give end show running config. Coming to this interface G0/0, here we can see IP access group 1 out. Also here we can see the access list to be created. Okay, also we can give this a show command, show IP. I think it's let me try with the show interfaces. We'll give a gigabit ethernet 0/0. Oh, not this one. We have to give it show IP interface G0/0. Let me try this. Okay, and here we can see outgoing access list is 1, and we did not set any inbound access list. That's correct. In the same way, we can verify in this router R2 also. Enable show running config. Okay, and here we can see G0/0 IP access group 1 out. Also here we can see the access list we created. We will try with the show IP interface G0/0, and here we can see outgoing access list is 1. With the two ACLs in place, network traffic is restricted according to the policies detailed in part 1. Use the following tests to verify the ACL implementations. Okay, now we will test and verify these ACL implementations. Here a ping from 192.168.10.10 to 192.168.11.10 succeeds. That means we are going to ping from PC1 to PC2. I will get the IP address. Here we can see that. We will ping from PC1. Okay, succeeded. Next is a ping from 192.168.10.10. That means from PC1 to 192.168.20.254 succeeds. That means from PC1 to this web server, right? So we will get the just I will copy this IP address. Coming to PC1, we will ping to the server, and it succeeded. A ping from 192.168.11.10 to 192.168.20.254 fails. That means we are going to ping from PC2 to this web server, and here we set access control list. This network is not allowed to communicate to this web server. So we'll go to PC2, command prompt, we will ping to the web server, and it should fail. We can see it says a destination host unreachable. Here we will see how it works using this simulation mode. We will switch to simulation, and here we will give a show all or none. We will keep only ICMP. And we'll close this window. Again we will go to PC2, then we will ping to our server. Okay, and here we can see that ICMP packet. We will capture and forward. It goes to this switch, then it goes to R1, and we can see it goes to R2, and this R2 is dropped this packet. Because we configured an access control list in this router R2 to deny this network 192.168.11.0 to this web server. That's why this router dropped this ICMP packet. Now this router will send an acknowledgement back to this PC2, and he says that packet is dropped. So we can see it goes back to R1, S2, and finally reaches to PC2. So here it says destination host unreachable. We will go to real time. Then ping from 192.168.10.10 to 192.168.30.10 fails. That means we are going to ping from this network 192.168.10.0 to this network. We will ping from PC1 to PC3. And here they clearly specified it will fail because we created an ACL in this router R3 that this network 192.168.10.0 is not allowed to access this network. We will copy this IP address. Then coming to PC1, command prompt, then we will ping to that PC, and we can see destination host unreachable. We can verify that using simulation mode. Here we have only this ICMP visible event. We will go to PC1. Again, we will give that ping to that PC3, right? And we can see that ICMP is generated in this PC1. It goes to S1, it goes to R1, then it goes to R3, but here we can see that packet is dropped by this router R3. Because we created access control list in this router R3, this network 192.168.10.0 is not allowed to communicate to this network 30.0. And now we can see this R3 is sending an acknowledgement back to this PC1 that it's dropped, it's failed. Here we can see that destination host unreachable. We will come back to real time. Then a ping from 192.168.11.10 to 192.168.30.10 succeeds. Just I will copy this address. Then we will go to PC2. We will ping to this PC3. Coming to PC2, command prompt, ping to PC3. It should succeed. Okay. And finally, a ping from 192.168.30.10 to our web server. We'll get this web server IP address. We are going to ping from PC3 to this web server. It's working. Next is issue the show access list command again on routers R2 and R3. You should see output that indicates the number of packets that have matched each line of the access list. Also, they given a note. The number of matches shown for your routers may be different due to the number of pings that are sent and received. Yes, that's correct. So we are going to give this show command, show access list in this router R2 and R3. Coming to R2, show access list, and here we can see 8 matches. We will go to R3, show access list. Here also we can see 8 matches. Here, why we got these 8 matches? And obviously this depends on the number of pings we made. Here we made 2 pings from PC1 to web server. I ping in a real time. Also I ping in a simulation mode. So twice we ping from PC1 to web server. So 1 ping means 4 matches. 2 pings, it's 8 matches. Yes, so this matches depends on the number of packets sent and received. Okay, that's all in this activity, that is configure numbered standard IPv4 ACLs. So here we planned an access control list, then we configured, applied, and finally we verified this standard numbered ACL. Here we can see our completion status. It's 100%. Now, dear friends, if you get any doubt or if you have any suggestions regarding this packet tracer activity, please comment below, or even you can contact our team using our website. Link you will get from the description below. And if you like our video, give a thumb and share with all your friends. Stay tuned, and we will meet again with the next packet tracer activity. Thank you.